Hello, and welcome to our final weekly science experiment, brought to you by Cornell Cooperative Extension. For our final week, I decided to not wear a crazy costume and to wear one of my Cornell shirts. I'd like to thank Cornell Cooperative Extension for having me to make these videos over the past couple weeks, and to thank Cornell University for an amazing 4 years, the past 4 years. This week, we are going to be making a super cooled water bottle. You may have learned in school that 32 degrees Fahrenheit is the freezing point for water. Did you know that water can get below 32 degrees and still remain a liquid? That might seem strange, but let's talk about it a little more. This is a process called supercooling. So just as water needs a condensation nuclei or a piece of particle to condense on when we're making like a cloud outside or something in the atmosphere, water also needs a condensation nuclei to freeze in a process called nucleation. So if we use purified water without any minerals in it, so no mineral water, this is pure, purified water, it will not have any nuclei in it, hopefully. So then we can cool our water slightly below freezing, and it won't have any nuclei to freeze onto. So we can get our water slightly below freezing and have it still remain a liquid. But that state of water, supercooled water, is super irritable. That means when we take it out in that state, even a slight perturbation, we can get it to freeze instantly. So that's what we're going to be doing today. What you need is one plastic water bottle and some purified water. So this is baby water. So it says specially purified for babies, purified water, and that's what we're going to try to be using today. I'm going to say now that this experiment out of our 5 is the one that may not work to plan, but that's part of science, is trying something and seeing if it works, and realizing that science is an imperfect science in itself. So we're going to try this, and we're talking about our hypothesis of what should happen and what can happen. And if we can't get it to happen, I'll show you a video of what it should look like so you can keep trying on your own, and I'll keep trying. But there's a lot of things that need to go right for this to work. What I want you to do is to take your water and use your funnel, or just pour it in. And so I've let this water bottle dry overnight because we want to get the water that's in it out, the old water. And I'm going to just put some of this water in. If you can find this packaged in an individual water bottle, that'd be even better, but I couldn't find it. So what I'm going to do is I'm first going to use this water to clean out this bottle. So I'm going to shake it all around, and then I'm going to go and empty it. Once I've done that, now I can fill this bottle to get it ready. What's important is that once it's full, we get ready to cap it very quickly to avoid any particles in the air getting into the water. Okay, so it's full. Now I've capped it tightly. Let's go over to the freezer now. Okay, so now I'm at the freezer and we're gonna put it in, and it needs to be in for about 2.5 hours to get it to the right temperature. We don't want it to get too cold. We want it to get just below freezing. Another key thing here is that you do not open the freezer for those 2.5 hours because we need this cooling to be really gradual. So I'm gonna go ahead and put it in, and I will see you in 2.5 hours. All right, it's been 2.5 hours. In the meantime, I put on another Cornell shirt that I have, Go Big Red. Let's see if it worked. Okay, so unfortunately, it did not work. Our water bottle is fully frozen here, and when I tried to figure out what's going on, I read the fine print on our water, and you'll see that it says, with minerals added. So I think that those minerals could have made it so that our bottle was not able to be super cooled. There's other things that could have happened along the way. As I said, this is a delicate experiment. I encourage you to try it again and again. Try to get a water bottle that you don't have to fill. Try just doing it with a normal water bottle. It's very easy to do, so you can just keep trying it. So yeah, I encourage you to try it. But because ours didn't work, I'm gonna provide a video of someone whose did work, and we'll give them some credit for their cool experiment. So here it is.
If all goes well, when you take the bottle out, you'll have yourself some super-cooled, below-freezing liquid water. But if you shake it up, super-cooled liquids are highly unstable. When they're below their freezing point, their molecules really want to form a solid, like really bad. The laws of physics are commanding them, but they just can't comply. And that is why, with just a slight provocation, those super-cooled molecules will snap into place. By slamming a bottle of super-cooled water against the table, you create a nucleation site, and you can actually see the ice crystal form almost instantly, which is super cool. Get it? Super cool?
Alright, so that was our goal. That was really cool. Unfortunately, we didn't get it, but I encourage you to try to get it. Thanks so much for tuning in over the past couple weeks. I hope you have a wonderful summer. Bye.